So hello, my name is Sascha Kattelmann from the pilot partner PST, and in this video I want to demonstrate the static code analysis module. So going back to the Rescale architecture, we can see that the static code analysis module is here on the top left, and it contains the actual static code analyzers, also formal verifiers, and then there's also the SSCG generator. And together with the dynamic testing module, it's part of the assessment domain. So this is one of the two modules which are used to assess software projects, software artifacts. And if we look into the architecture of the static code analysis module, again here we can see that the input to the module is the source code of a software project and also the S-BOM. Then there's also a tiny bit of configuration which is used to process this source code and the S-BOM. And at the end there is the SSCG generator which aggregates the test results and publishes it to the management module. So with that being said, let's move over to the actual demo. And I want to briefly explain my setup here. So in the foreground, you can see my shell, which I will use to execute the static code analysis module. And in the background, you can see the Rescale dashboard where components are registered. And I also have a software project here in place. So the demo folder here contains an Erlang folder. So this project will be, the software project will be about Erlang. And there is an input for the static code analysis module consisting of two parts. First, the actual software project with the source code. So this folder contains the whole software project, including the source code. And there's also an S-BOM for this project called GRISP. GRISP is a library from the pilot partner PST. So it's always these two parts. And then there is also an output folder, which will later on, after the execution of the module, it will be filled with the actual SSCG and test reports for local inspection. So what we need to do now first is we need to register a component in the Rescale dashboard. Let's call it GRISP demo. It's written in Erlang and description is optional. So I'll add it here. The site is refreshed and we can see here in the bottom there's our GRISP demo. And the SSCG status is currently unavailable. And the actual generation of the SSCG can be triggered here with this button. You will get an access token here, which is used to communicate with the Rescale infrastructure. And I have a little setup here which allows me to export the user access token in an easy way. And then using this token, I could just start the static code analysis module. But first I want to show you using the Docker images command that I have the static code analysis module locally on my machine. It's pretty big, over 2.3 gigabyte, and that's the reason I downloaded it before this demo, but it's for everyone who has access to that piece of Rescale specific infrastructure. It's no problem to download this Docker container. Then I have this little shortcut to actually start the process. So when I execute this, there is a wall of text appearing, and I will just start it now, and then I will explain what's going on. So here in the bottom, you can see that there is some sort of scanning going on, but I'll get to that in a minute. First of all, there is a bunch of configuration parameters here in the beginning, which I will explain now. So there is the docker run command executed on the image I mentioned before. So this image is not downloaded. It would be automatically downloaded if it wouldn't be there in the local cache. Then in the beginning, you can see that there are volumes mounted into the container. So there is the input folder, which is mounted into the container internal user files folder. The same with the output folder. So we can later access these files without any problems. Then this big string here is the user access token, which I copied from the dashboard. Then there is the language information, which is set to Erlang. So we are currently scanning an Erlang project, and that information needs to be provided in that variable. Then there is a path to the source code, which is provided here. The path to the S-BOM. And then we have a variable called dry run, which is set to false. So dry run means that if set to true, that the SSCG would not be published to the Rescale platform. So in this case, it's set to false. So it's going to be published to the Rescale platform. And we also need an endpoint where to publish it to. And this is the management module address, which is set to this URL. And here in the logs, you can see that first of all, the S-BOM of the software project got validated because later on the metadata and other things from that S-BOM are taken and partially copied into the SSCG. And if this S-BOM is invalid, there's really no point in moving on here because later on it would fail. Then you can see there is something Erlang specific going on here. This is because the language information was set to Erlang. And at the moment, we just have one tool which analyzes Erlang software. And that tool is called SaveMe. So if there would be more tools, then also the other tools would be executed. But at the moment, there's just one. And SaveMe is an AI enhanced tool based on a large language model called CodeBird. And in Rescale, we enhanced CodeBird using additional training data that we generated using quite a bunch of other tools. And yeah, that's also the reason why this Docker container is pretty big, because the language model behind that is pretty big by now. So then later on here, you can see that the Erlang source code scan was completed and the SSCG generator got activated. So it generated the SSCG. It was also provided to the output folder and also validated. And then because the dry run is set to false, the SSCG generator also published the SSCG. And that completed the whole process. So if we look here into our demo folder again, you can see in the output there is the actual SSCG now, and there's also a folder with the test reports. And going back to the Rescale dashboard, so let's refresh it. You can see here in the bottom, oh, there is the SSCG status available, and it's even possible to inspect the JSON here. So I will not get into details here because this document is just too complex. But here you can see a bunch of metadata like a serial number for the SSCG, a timestamp. You can even inspect the parameters we set in the static code analysis module. And further below, there is the actual test data, which is encoded using base 64. So you have to decode it before you want to inspect it here. So that concludes the demonstration. Thank you very much.